Yeah, hi everyone, Mr. Market here. In today's video, I'm going to show you how to calculate compound interest when that interest is compounded annually, so each year. In my previous videos, I've showed you how to calculate simple interest using one variation of the simple interest formula. We also use that rearranged formula to calculate principal, interest rate, and number of years. But today, we're looking at compound interest because compound interest is actually more common or commonly used when taking out a loan or investing money. The main difference between a simple interest and compound interest is that with simple interest, you're only earning interest, and I'm just looking at investing here, you're only earning interest on the original principal that you invest. With compound interest, you're earning interest every period. So in this case, the example I'm going to be looking at today, it's every year. And then you're earning interest for the second period, say for example in the second year, on the principal and the interest you earned in that first year. So the interest is added to your original principal, and then interest is earned on that over the following periods. Hence, it's compounded each period. Anyway, let's get into an example. I'll do two examples today. Again, this formula that I'm using today is just one variation of the formula. They all sort of do the same thing, but the formula I'm using is from the Hazy textbook, and it says FV, which is the future value, is equal to PV, which is the present value, multiplied by 1 plus the interest rate to the power of n. I is the interest rate per year as a decimal, so convert that to a decimal by dividing by 100, and n in this case is the number of years. Okay, to the power of the number of periods. Today we're looking at a period being a year, compounded yearly. So let's get straight into the first example. $5,000 is invested for 4 years at 7% per annum and is compounded annually. What will the amount be at the end of the period? So let's just look at what we do have. The present value, which is the initial principal, is $5,000. The interest rate, well, that changed purple, doesn't matter. Interest rate is 7% per annum. But remember, we're going to convert that to a decimal by dividing by 100. So that changes it to 0.07. And, excuse me, the number of years in this case, in this example, is 4 years. So what we're going to do is put those values straight into the formula there. So the future value is going to be equal to the present value, which is 5,000, multiplied by 1 plus the interest rate 0.07, okay, to the power of n being the number of years, 4. Put that in your calculator, and $5,000 times by 1 plus 0.07. Of course, you can simplify that if you want already. It's not that hard. To the power of 4 years. So the future value will be, or at the end of 4 years, your investment will be worth $6,553. And to the nearest cent, 98 cents. So 6,553 and 98 cents. And it really is as easy as that. Now, remember, this example today, the video, we're looking at interest being compounded annually. The next video I'll do will look at if interest is compounded at a different rate or a different period of time. So, for example, monthly or quarterly, etc. So stay tuned for that. The last example I'll go through today is doing a little bit of backtracking. So in this example, it says 3 years ago, Holly invested amount of money in an account paying 6.2% per annum interest, which was compounded annually. Its value is now $5,497.77. How much did Holly invest? So what we do know, we actually know the present value. We know the interest rate, and we know it was 3 years. We need to work out that present value. So I'm just going to write down what we do know at the moment. Like I said, we know the future value is, well, the value right now is $5,497.77. We know that the interest rate is 6.2% per annum. Again, if we're converting that to a decimal, it would be 0.062, and the number of years is 3 years. Okay. So I'm actually going to put those values straight into this formula. It'll look a little bit different because all of a sudden we actually know that the future value, which is on the left-hand side of the equation or the subject, so $5,497.77 is equal to, what we don't know, what we're trying to work out is the present value, which is a little bit confusing. It says it's now 5,497. The initial amount that she invested is what we're actually trying to work out, the initial principal, okay? Times by 1 plus 0.062 to the power of 3 years. In this case, I am going to use a little bit of algebra to do some backtracking, because like I said, this is, or FV is now our subject, and we're trying to work out an unknown that is on the right-hand side of the equation, and it's not isolated. So I've got to, I guess, get that present value by itself, make it the subject, and I guess remove all this other stuff from the right-hand side here. So basically, what's happening between this variable, PV, and the rest here is multiplication. So what I'm actually going to do is I'm going to divide this whole side by 1 plus 0.062 to the power of 3. And if I do that, I'm actually removing it completely from the right-hand side and making PV the subject over there, which is what I want. But to keep this equation balanced, I also need to divide the other side of the equation by 1 plus 0.062 to the power of 3. Okay? Which is, you can do. That's basic algebra backtracking. So the present value, or what we're actually looking for, the initial principal that was invested, is equal to $5,497.77 divided by 1 plus 0.062, or 1.062 to the power of 3. Anyway, I'm just going to put it in the calculator as it is. Excuse me, over here, so 5,497.77 divided by 1 plus 0.062 power of 3 equals, so to the nearest dollar, it's $4,590. So what that means is that 3 years ago, Holly must have invested $4,590. So the present value, $4,590. Okay, hopefully that helps. Again, just 2 basic examples on how to calculate compound interest. When that interest is compounded annually, the next video I'll do is, again, compound interest, but when that interest is compounded at a different rate. So like I said, monthly, quarterly, etc. Thanks for watching, guys.